Well, thank you for that introduction, and really excited to be here and talk a little bit about some of the research that I've been involved with in several different systems using fire to manage for deer and turkeys. So in terms of deer and turkey habitat requirements and things that we want to manage for, you might be thinking, well, why deer and turkeys? Not only are there a lot of people that are interested in managing deer and turkey on their private lands, in fact, over 360. Oh, there the microphone. Okay, this is that good? All right. So within the eastern U.S., over 360 million acres are leased or owned for hunting, and most of that hunting is for deer and turkey. So these are the focal species on a lot of those properties. And in fact, just stepping back and thinking about why people burn on their lands, this is some data that John Weir pulled from some prescribed burn associations in Oklahoma. And obviously, we have some different resource objectives, but there on the x-axis you can see the reasons why people burn, and on the y-axis is the number of burns as well as the acreage of those burns. Now, those first two things you might be thinking, well, red cedar control and livestock production probably aren't that important in my state. But the third thing on that list is wildlife habitat. And in fact, 70% of the burns that happen in Oklahoma within PBAs, which is a large majority of the burning that's happening on private lands, are actually happening with wildlife habitat management as an objective. And so specifically for deer and turkey, oftentimes objectives associated with both private and public landowners, but especially private landowners, we're thinking about increasing antler size as well as body size of deer, fawn production as well. And then in terms of turkeys, we're oftentimes wanting more turkeys on a property. There's been a lot of issues and concern about wild turkey decline here recently, and certainly burning can help solve that. But I hope if you're not interested in deer and turkeys that I hold your attention for a little while, because again, there's great opportunities here to improve things for various objectives, working with landowners as well as the general public to help educate them on reasons why fire is a good tool. Deer and turkey obviously are generalist species, but they do have specific life history characteristics that work really well to promote some of the open woodlands and savannas and early successional communities that are in decline in the eastern U.S. And regardless of whether you want to manage for deer and turkeys or you're worried about species like red-headed woodpeckers, great crested flycatchers, or fence lizards, certainly there's good opportunity for synergy and working together towards those objectives. Now, in terms of specific things we oftentimes think about when we're trying to improve habitat for deer in the eastern U.S., really the first and foremost thing is thinking about increasing the availability of forage during the growing season. A deer eats on average about 5 pounds of food per day, and not only is that a lot of food, that's just dry weight, by the way, after you dry the leaves down. It also needs to be high enough quality to support things like antler growth and as well as lactation and gestation. And so thinking about the quality and the types of plants that are in an area is really what determines the nutrient availability. This graph here just shows the average nutrient quality of various plant types, including forbs, semi-woody plants, which would include brambles and vines, and then woody plants, which would include trees and shrubs in the understory. And as you can see, forbs have the greatest nutrient quality, both for crude protein as well as for phosphorus. And in fact, those are the only plant types that consistently meet the requirements for lactating does as well as bucks growing antlers. And so really we want to be thinking about promoting forbs, but fire also does something to woody plants that can help increase their value. Rainer Nichols did some work in Mississippi showing that burning during the growing season as well as mechanically cutting trees, but here's some data from burning during the growing season. We can actually increase the nutrient quality of the leaves in some of those plants as they try to balance the nutrient balance between the roots and the shoots. And so we can take something like a red maple that was previously providing, say, 9 to 10% crude protein, and suddenly it's bumping up to almost 18% protein. And so that's really a great opportunity to increase the quality. We can also manage for the structure of these communities to provide things like fawning cover. Typically we're thinking about having vegetation up to at least 3 foot tall, maybe a little bit more woody structure for fawning cover. And then bedding cover, obviously, we can increase that even more. And although these probably aren't limiting for populations, of course, for private landowners that want to hold deer on their property, these are things we can think about and consider working into our burn management. For turkeys, there's really two primary vegetation structural characteristics that we're thinking about, and those are nesting and brood rearing cover. We really focus in on those reproductive cover types for turkeys, and specifically for nesting cover, we're generally thinking about promoting a plant community that's 3 to 4 foot in height with some overhead cover, usually associated with a shrub or a sapling, as well as screening cover along the sides that generally could be associated with woody or herbaceous plants. But something I will mention that's relatively new that we have coming out here soon is the effect of woody plants on hen survival. Turkey nest success usually averages 20 to 30%, and that's not great, but we can certainly have turkey populations in areas with nest success like that if we have high hen survival. But recent data indicate that hen survival has declined, and of course, if a hen's getting whacked while she's on the nest, which is the most common time that they're killed, those populations are probably in decline. And so this data showed that cover around the nest, that is just having good screening cover up to about 3 foot in height, that's good for the hen, and it's also good for the nest. But if you start to have extensive woody stem coverage, that's actually bad for the hen. And so if hens are forced to nest in woody thickets, that's going to be negative. We also think about brood rearing cover, and probably on the vast majority of properties in the eastern U.S., this is the most limiting thing for turkeys, is having an open, forb-dominated community, not dominated by grass, also not dominated by woody plants. It's relatively open at ground level. And that's really, to me, the number one key thing that most sites lack for turkeys. For the rest of the talk, I'll be focusing in on fire, obviously, but I don't want to, put the cart before the horse. And I want to mention that, if we're just thinking about burning in closed canopy woods for deer and turkey, we're not really doing much to move the needle. And so having at least 30% sunlight on the ground is kind of a prerequisite to thinking about fire management. So whether that involves a commercial harvest, such as a shelter wood with reserves, or going in with forest stand improvement and killing trees using hack and squirt and girdle and spray, getting sunlight on the ground is kind of step number one to really promote habitat requirements for these species. I'm going to just briefly talk about things influencing fire effects. I know that y'all are probably familiar with most of this, but I want to mention it just before we get to some of the specific work, just to mention the importance of varying factors. And so, thinking about how often we burn, that's by far the most important thing in terms of determining not only the response of the vegetation, but also, more appropriate for this talk, the habitat requirements that we're providing in those areas. And, I'm speaking with generality here, but usually if we burn something at least every 3 years, but really more like every 1 to 2 years, we're going to tend to be promoting more forbs and a more herbaceous community, which is going to, on average, have better food resource availability, as well as promote brooding cover. Now, if you're in Florida, you probably want to bump that up to, a 1 year fire return interval or 1.5. Whereas if you're in northern Pennsylvania, you can back off of that. But certainly more frequent fire is needed for food resources and brooding cover. Whereas if we're trying to promote things like nesting cover or bedding cover for deer or fawning cover, we can up that fire return interval. But the take home here is the typical standard burn every 3 to 5 years for deer and turkey is not frequent enough. On the vast majority of sites in the central hardwoods and eastern U.S., I mean, if you get into the Northeast, that holds true a little bit more. But burning every 3 to 5 years, you're maintaining a woody thicket on most sites, and so we need to have more frequent fire for these species where they're an objective. Kind of going along with that, obviously we can have varying fire effects with differences in intensity. And intensity also interacts with the timing of fire throughout the year, and I'll get to that here in a minute. And we can also think about the time of year that we're burning. A lot of focus has been put onto this, and I've been part of several projects here recently that have looked at the timing of burning throughout the year. Obviously a lot of fire, both historically as well as today, happens during the dormant season, and there's certainly a lot of good things that can come from fire that time of the year. But there's been increased interest recently in burning during various portions of the growing season to try to promote different plants. And the effects are relatively subtle, but this is some work that just came out from Jake Bones. He was a graduate student that was working in the lab with us and at Tennessee. And we found that late growing season fire and dormant season fire, on average, compared to other times of fire, tend to increase forb coverage, with the greatest increase coming from late growing season fire, which would be burning during September and October, whereas burning during the early growing season, so in April and May, or during the fall, tend to reduce woody plant coverage the most. And so, the time of year can have an effect, but those effects are relatively subtle compared to the frequency. So don't get caught up too much in burning during this time of the year or that. Maintaining the frequency is most important, and then think about the seasonality after that. Speaking of seasonality, it does, one of the more interesting things is that makes it a little harder to look at the nuance of fire timing. Obviously, every burn's different, but on average, if you burn during either the dormant season or during the early growing season, you tend to have hotter fires, using the same firing techniques, similar fuel types, etc., compared to burning during the fall. And I think this is a great opportunity, especially for folks that are worried about using fire, worried about killing trees, etc. Burn during the fall. Usually, most of the time, the fire intensity is less, and it's also a time when not as many people are burning, and so you can get more accomplished because of that. Moving into some of the specific projects worked on, this is data from some work at Chuck Swan State Forest in East Tennessee, looking at the effects of fire timing in upland hardwoods on deer and turkey habitat. Within this, we had 3 different treatments. We had a control stand that was unburned and uncut, so just typical closed canopy hardwoods that were about 80 years old, 80 to 100 years old. And then we had areas that were cut with a shelterwood harvest with reserves and burned during either the early growing season in April and May or during the late growing season in September and October. And as you can see, just looking at them, obviously, first off, there's a lot more understory plant coverage. So we're going to be providing more resources for deer and turkeys. But there's also some clear structural differences based on just the fact that the early growing season in this photo was burned about 2 months prior, whereas that late growing season burn occurred about 9 months prior to that. And just on the average, thinking about habitat requirements, the early growing season, we're tending to provide better brood rearing cover for turkeys, and we're also tending to provide better nutrition for deer, whereas that late growing season fire is providing a little bit better nesting cover because of the taller structure, as well as better fawning cover for deer. But I want to emphasize that either one of these is providing much more resources than that unmanaged control. Specifically looking at the effects of fire timing on deer forage availability, the graph on the left just shows the biomass of selected forage plants within the control, early growing season, and late growing season unit. There was over a 500% increase with either of those treatments. So we've greatly increased food availability for deer. And although the actual numerical difference there shows that the late growing season had a little bit more biomass of food, they're not different statistically. And in fact, the early growing season actually had better nutrition because of all those resprouting plants. And so on the average, that early growing season is going to provide the best nutrition, which is interesting because we'd expect to see a wave of the deer following that nutritional pulse, which that's exactly what we see. This graph is showing some results from camera traps placed about a month after that early growing season fire and about eight months after the late growing season fire. As you can see, during either May or June or during July and August, we see greater deer use within the treated stands. So no shock there. We've got more cover, more food compared to the unmanaged control. But especially in May and June, right after that early growing season burn, those plants are resprouting. And even though the biomass of the plants is a little bit less during that time, the quality is better. And so we see deer following that, whereas by later in the summer, the nutritional quality of the plants is evened out. And so we see equal use between those treatments. We also see that the timing of fire, the effect on the structure translates into different turkey use. And so we see that burning during the early growing season in April and May, which, yeah, it's during nesting season, but we do see greater use of those areas by turkeys because of the reduced structure. Now, we probably would see the same results if we burned in the dormant season, if folks were, concerned about that. I think it's overstated based on the data that's out there. But if folks are concerned about it, you can also burn during the dormant season and have similar structure here. But the take home here is the turkeys are selecting for that most recent burn because of the structure that's present there. Moving a little bit west, also been involved in some work in the cross timbers forest in Oklahoma. If you're not familiar with the cross timbers, they're dominated by blackjack and post oak. They're a relatively open system that have intermixed openings that are dominated by herbaceous plants. and it really serves as an ecotone between forested and open systems. It's a really neat system. It's something that I wasn't very familiar with before coming to work at Oklahoma State. There's a lot similar here to managing in a lot of eastern hardwood, more eastern hardwood forest. Main difference is the trees are a little shorter because we get less rainfall. And these systems are really driven by frequent fire. There's a lot of fire that still occurs within the cross timbers. In some places, though, fire is backed off. And so as part of this project, we're interested in looking at how differences in large-scale fire might influence wildlife use to hopefully help tell us what deer specifically here are selecting for, and actually took advantage of a large wildfire that occurred. So we had varying fire intensity. But again, I don't get caught up on the fact it's a wildfire. I think the results would have been the same if it was prescribed or wildfire. This just gave us a little bit bigger scale to look at things, to look at varying intensity. And this graph here shows results from cameras that we placed out in areas that were burned. These were all burned on the same day with the same conditions relatively, but we had differences in intensity. And in some places, we didn't have top kill of cedars and a little bit of top kill of some of the woody stems in the stand. And those didn't have as many forbs compared to the places where we had greater top kill of the overstory. And we see that deer are selecting during the growing season for places with greater forb coverage, which really is just driving home again the importance of forbs for these species. Moving a little bit to the south, I've also been involved with some work in coastal plain hardwoods as some of my masters that I did at Auburn University with Will Goolsby. I think these are really undermanaged and undervalued systems. Most of the time we think about in the coastal plain burning pine forests, and then we think about bottomland hardwoods down in the bottoms. But a lot of properties have these little mixed species stands of coastal plain hardwoods, and you can view this as a pro or a con. But a lot of the times they're small in size, and there may not be a timber market to be able to move that wood, and so we can use forest stand improvement in these stands without giving up all that much timber volume and production. But currently, most of these stands, really all that they're providing for deer and turkeys are acres. And so we can improve those stands, increase understory sunlight, and hopefully provide greater food resources and cover resources as well. One of the other things we were interested in looking at was, in these stands, because of the mixture of species, you've got some species like white oak and southern red oak that have a fair amount of fire tolerance, and they also have leaves that are going to burn better compared to water oak that's also mixed into some of these stands. But you talk to some managers and they start to get a little nervous if you're talking about burning in a water oak stand. And so we wanted to see, well, how is fire actually going to affect the trees as well? So in terms of the fire effects in this study, we applied forest stand improvement, again, going in, just doing girdle and spray on these stands, and then burning them during the dormant season. And within 3 months after the fire, we saw a 500% increase in forage availability in places we'd applied FSI, as well as places that we'd applied FSI and paired it with fire. Now, I'll mention here, the FSI and burn, similar to with that early growing season fire, although the forage availability is the same, the nutrition is going to be better in the area that we burned because of those woody resprouts. And we really saw an excellent understory response. Again, this is less than 2 years after we killed trees, and just a few months after that first burn that we applied, we took a closed canopy stand and turned it into something that's providing excellent brood rearing cover for turkeys, and again, deer forage as well. And perhaps best of all, for those that were worried about it, we saw relatively limited damage to oaks using low intensity fire like this. And in fact, the only species we saw any damage to from oaks or other mass producers was water oak, and only 13% of the water oak total within the burn stands had any damage at all, and it was just very slight damage to the cambium. It wasn't, dead exposed wood. And so certainly the results that we got indicate, yeah, it's certainly worth that slight bit of risk to some water oak within the stand. And so wrapping this up, we can use fire to promote various resources for deer and turkey by changing our timing of fire as well as the season of fire. Forb production is extremely important within these stands, and we definitely want to think about increasing forb abundance within the stands. And finally, I'd encourage you to start thinking about using fire throughout the year. And instead of thinking about burning as a discrete tool to use during one time of the year to set back succession and then come back 3 to 5 years later and burn it again, instead think about opening up the burn window, burning during different times of the year, not only is that going to increase your ability to put more fire on the ground because you have more burn days, you're also going to be able to promote more diverse conditions for both deer, turkeys, as well as a variety of other non-game species. With that, I'd like to thank some of the funding agencies that were involved in making this work possible, as well as the universities where it took place, as well as several technicians, graduate students, and other faculty that helped make some of this work possible. And with that, if I've got time, I'd be happy to take any questions.